All right, lesson 4. In lesson 4, we're going to talk about another way of solving a system using algebraic processes. So to start, it says, so far we've used 2 methods to solve systems of equations, graphing and substitution. In this lesson, we'll learn another algebraic technique, the method of elimination. This method is particularly useful when the equations involve fractions. Okay, so as you see, there are 4 more steps. We're going to go at it the same way. We're going to get down to only one variable. We cannot solve an equation that has 2 variables in it unless we have 2 equations. So we're going to try to get to one, solve for one variable, plug that one back in like we did in substitution, find the other variable, and then, of course, we would always check. So in elimination, in the process of elimination, it means just what it says. We're going to eliminate one of the variables. So if I consider these 2 equations together, and I say, what would happen if those are both equal, like one's equal to 13, one's equal to 2? What would happen if I actually pushed them together? What if I combined the equations together? If I did, you would notice that this would turn out to be 5x's. I'm combining here. And then a plus 7y and a minus 7y turns out to be 0. And I would get 15. So is that true? Could I then just go ahead and divide by 5 and make x equal to 3? Is that a possible answer? And then what would you have to do? Because these are 2 straight lines, they're both linear equations, they're going to intersect. They're going to intersect at a point, and every point has an x value and a y value. So I would then have to take my x value and plug it back into one of the other equations. It does not matter where. Put it back in. So I'll put it into the first. I'm going to start to copy. Everywhere I see an x, I'm going to put a 3. And then just copy the rest of the equation. Go ahead and finish. Do the math. Wow, that was quick. According to this, the value of x is 3 and the value of y is 1. So my answer here is 3 and 1. And it says verify the solution satisfies both equations. Let's go make sure. Does that work? Does that point, 3 and 1, the x and the y, make both equations true? So we'll start with the first one, and I'll copy, and everywhere I see an x, I'm going to put a 3. Everywhere I see a y, I'm going to put a 1. I'm just plugging that point back into the first equation. Do the math. All the way down, left side and right side. Yeah, it worked. Okay, let's try the other equation. So if I said 3 times my x minus 7 times my y, would that be 2? Do the math. Wow, it does work. So that equation is verified and it works in both. So what did we do? Those 2 equations were set up in such a way that when I combined them, the y's zeroed out. Your plus 7y and your minus 7y, when I combined, they were eliminated. The y's were eliminated, and I was left with one variable x, which I could then solve. So that is the game plan. When you are trying to do elimination, you want either the x's or the y's. It does not matter. You want them to, when you combine them, you want them to become a 0. You want them to be eliminated. I do not talk about adding or subtracting the equations. I always talking about combining them together. So if we were to look at class example number 2, it looks like it almost works. The x's could almost be eliminated if only one was a positive and one was a negative, right? Because the way it is right now, you'd have 4 x's plus 9 y's equals 10.5. That would not eliminate any of the variables. However, if I could multiply this bottom equation by a -1, the whole thing, both sides of the equal sign, folks, both sides of the equal sign. So important to do that. The other important thing is to copy them down over on the side so you don't get confused. I'm going to multiply the bottom equation by a negative, which turns this into these answers. So it's -2x minus 3y equals a -4.5. Don't forget the whole thing. Then I can combine them. And when I combine them now, the x's will be eliminated. So you see that your goal is to have pick one of the variables to be eliminated and have the coefficients be opposites. So if one was a 2, the coefficient of the other has to be a -2. That is how you eliminate the variable. And then we would have 6y and a -3y. It leaves me 3y. And 6 and a -4.5 is 1.5. Divide both sides by 3. And y turns out to be 1/2. Okay, now you're not done, because if y is a half, you have to go solve for x. Remember, two linear equations intersecting at a point, an x and a y value. So now you're going to take the 1/2 and plug it into either spot. I'm going to go back into the original first equation. I just think it looks easier. So I'm going to go 2x, copy, copy, copy. Oh, there's a y, put a 1/2 instead. And go solve for the x variable. You have to have the x and the y. So just do a little math. Half of 6 is 3. Subtract your 3, and 2x is going to equal a 3, which means x is equal to 3 over 2, or 1.5. Okay, there's my x value, there's my y value. That is the solution to the system. It is 3/2 and 1/2. That is the x and the y. That is the point where they will intersect. Then it says verify. Okay, we will. I will take the time to verify. Kind of came down there. So to verify, I have to check in both equations. So I will start in my first equation. Let's make it purple. So I will say 2, there's an x. Put your fraction. Don't worry about it. It's all right. Put your fraction in. Don't panic. Okay, 2 times 3/2, your 2's will cancel. This will become 3 plus 6 times a half is a 3, half of 6. And then I have 6 equals 6. Cha-ching. Good. Verified in one. Let's do it one more time in the other. So I'm going to go to the second equation. Everywhere I see an x, I'm going to put 3/2. Everywhere I see a y, I'm going to put 1/2. See if it works. So those will cancel. I have 3, and then 3 times a half is 1.5. And lo and behold, I have just verified my solution in both equations. It works in both. Then, hence, I know that my solution is accurate. All right, so let's go over it again. How do I eliminate? What's this process of elimination? Picking a variable, and either one, pick the easiest one, and then making the coefficient of them be opposites, so that when you combine the equations together, those variables zero each other out. So when I look at 2x plus 3y equals 4, class example 3, and 4x minus y equals 22. Now, I could do, nothing is going to work the way it is right now. Nothing will be eliminated. If I chose the x, perhaps I could multiply the top equation. I want it to be a -4. So I would multiply the top equation by a -2 everywhere, all the way across. Or that would get rid of the x's, wouldn't it? Another option, there's no right or wrong here, is to get rid of the y's. If I wanted to get rid of the y's, I could multiply, this is a plus 3y on the top. I could multiply the bottom by a 3 everywhere, which would turn this middle term into a -3y, and then it would work, right? So first of all, let's answer the question, does adding or subtracting the equations eliminate either of the variables the way it is? And the answer is no. However, they're saying, but look, let's go ahead and multiply that second equation by 3 everywhere. So when I multiply this by 3, I will get 12x minus 3y equals, don't forget to do the 66 over there. 3 times 22 is 66. Okay, so I'm going to put the original first equation up there. It was 2x plus 3y equals 4. So I put this equation, I leave it the way it is, and I only mess with the bottom one. Now when I combine the equations together, these will cancel. Plus 3y and a -3y is gone. I have 14 x's on the left, and I have 70 on the right. And when you're going to divide by 14 right there, I'm just checking where I am. Okay, so let's divide by 14. X is going to equal 5. So that is my solution for the x. Now you have to plug into one of the original equations to find the y. Never forget that you have to find the x and the y. I'm going to plug into the first one. So I'm going to get 2 times 5. See, now I only have one letter. I can solve this. Boom. There is your x and there is your y. Good. It says verify. To verify, you must check in both equations. So get busy. Here comes the first one. First equation, x is a 5, y is a -2. It doesn't take long. Quick. Done. Was that 10 seconds? It's not very long. The second equation, copy 4x is a 5, y, careful. You see it there, right? It's a -2. You can see how if you didn't put brackets in, you would be wrong. So check your work. Sure enough, it works. That's my check. Okay, this is my check or my verify. Okay. Now it says consider the original system, multiply the first equation by an appropriate number that will eliminate the x. So that's where I started to say you could have multiplied the top equation by a -2, which would eliminate the x. I'm not going to do that. Let's go on down. Class example 4 says consider the system of equations. Choose appropriate whole numbers to multiply each equation by so the system can be solved by eliminating b. Okay, they happen to choose the b. And because neither one looks simple. The A's are going to take some work and the B's are going to take some work. But let's just choose. So we're saying, okay, let's choose the B's. Let's eliminate the B's. I want the coefficients of the B's to be opposites of each other. So 3 and 7 don't work together very good until you get to 21. If you chose the top one to be 21b and the bottom to be -21b, then they would be eliminated. So we are going to multiply the first equation by a +7. The bottom equation, we will have to multiply by a +3. See, we're going to get rid of these b's by making them become 21s. Now, the signs are already good. Don't mess with the sign. Positive and negative, that's great. We just have to make the 3 and the 7s become 21. So when I do that, you must multiply the entire thing by 7. Here we go. Give yourself some space. It takes a lot of work. 35a plus 21b equals 21. Don't forget the 21 on the other side. The bottom equation will become 9a minus 21b. It's going to work. And 81 times 3 is 241, I believe. 243, sorry. Okay, so now I'm going to combine those two new equations. These are going to become zeros. 35 and 9 is 44. And over here I get 264. And I'm going to divide by 44. And I get a to be 6. There's 1 point. That's one step. A is 6. Don't forget, you have to solve it. Solve the A and the B. So take that number, and now we're going to substitute that value of A into either equation. I'll pick the first one. So 5 times, there's an A. Copy, copy, copy. Do the math, do the algebra. Solve for B. Divide both sides by 3. Divide by 3. I'm not going to show it. I'm running out of room. And B is a -9. All of a sudden, your answer is A is 6, B is a -9. Solve and verify. I must verify if I want to get all my points, all my marks. So I take my two answers, my A and my B, and I plug it into the original equation. It just takes 30 seconds or less even. Boom, it works. Do the next one. Don't ever forget to verify in both. Copy and replace or substitute. By the way, if your check doesn't work, don't manipulate your check. Go back and maybe you made a mistake in your question. Okay, that's if we eliminated B. If we wanted to eliminate the A's, I would have chose them to become 15s. So top times the top by 3 times the bottom by 5, but you would also have to multiply by a negative. Okay, I'm not going to do it because it's the same process, but that's what you could have done. Okay, 2 more quick questions. Solve the following system of equations using elimination. Okay, now we have a little bit of a problem, folks. They're not lined up together. If I wanted to write the equal signs underneath here, like this, I have a mess. That doesn't work. So before you start, it's important to have them written in such a way that we can manipulate them easily. So let's put X and Y on one side and the number on the other. Just doesn't really matter what you choose to do, but just be consistent. Make them both look the same to start with. So I'm going to leave my 4X and my 2Y, and I'm going to take my 13 and add it to both sides. So then over here, I'm going to put my 3X and subtract the 5Y to bring it over to the right-hand side, or the left-hand side. So now I have my X's and Y's on one side and my constants on the other. Now, if I go to line these up underneath each other, you will have to choose which variable you want to eliminate, X's or Y's. You choose, it doesn't matter. I'll go with X's just for a good time. So if I want to eliminate the X's, the coefficients, the fastest I can do is make them both be 12s. One got to be a positive, one has to be a negative. So I will times the top equation by a positive 3 to make that coefficient of the X be a 12. So here we go, going this way. Be sure to multiply the entire equation by 3, even the 13. The bottom, I will need to multiply to make it a 12. I'll have to multiply it by a 4, the X, so everything. But I better make it a negative so that I have opposites. One's a positive 12 and one's a negative 12. So when I do that, I will get, oh, shucks, 104, and it's negative. Okay, now we will put the two equations together, smush them together. This becomes a 0, and you have 26y equaling 65. Oh, that is not pretty. However, I think it's going to be right. So I'm going to divide by 26. Five over 2. Oh, this is a negative 65. My bad. So it is right. It is negative 5 over 2. When I divide that in bracket, I get y to be negative 5/2. That is correct, by the way. I double checked my book. So it just takes a little, it's ugly for sure. Okay, remember I have to find the X value. So I have to use substitution and put it back into the original, one of the originals. So I'll go with the first one. 4X plus 2. Oh, there's my Y. Replace it or substitute. I'm just going to kick the 13 over already. Just add 13 to both sides. So now when I continue to do my math, these two cancel. You get minus 5. Add 5 to both sides. Divide by 4. X equals 18 over 4, which is 9 over 2. Okay, there's my X value. There's my Y value. All right. Doesn't say to check it, but you could either using a calculator or doing it by hand. All right, the last one is pretty ugly, you guys. We can do it. The first thing, maybe I'll leave it for now. Maybe we'll come back to it later. But okay, I'll show you what I would do to start with. The first thing is I would simplify. So I would get rid of both of these fractions. If you recall, if you times by the common denominator only on the top, however, you do it everywhere, then those will cancel and you will have a 5. Remember doing that? Common denominator of 5 and 3 is 15. So you get 5x minus 10. And then over here, I'm going to get a 3, but don't forget you have a negative. So I'll just write it down because the negatives make me nervous. And then you would get 30. So you would start working with this and trying to simplify it as far as you could before you went to start eliminating. So I would have 5x minus 3y. I would add 16 to both sides to get rid of these. I would get 46. Okay, there. That's a nice one that you could work with to try to eliminate. Over here on the other fraction, the denominators are 5 and 2, so I multiply everything by a 10 on the top. So this becomes a 6, and this becomes 4 times 2 is 8. Following me? And 21 times 10 is 210. Oh, sorry, this becomes a 5. And 21 times 5 is 105. Okay, so a little bit more work here. So the point is that you have to do a lot of work before you even begin. And I don't even know if you remember how to do that, but that's a good reminder. So 6x minus 8y. Now I've got 30 on the left that I have to subtract. So subtract 30 from the other side and you get 75. Okay, now we're to a point where we could start working. And you would put those equations, maybe go for, I don't know, 30 on the front end, or eliminate your x's and y's, and that would be complicated, but you could do it. I'm going to stop now because I don't want you to get tired of watching, and hopefully you'll be good to go from there.